Okay, so this next question here, we've been given a coordinate 3, 4, so that defines that angle theta. And since we're given the coordinate, we have an x length and a y length. Okay, so our x length is 3, our y length is 4. Okay, so there's the opposite, there's the adjacent, and we can use those two lengths to work out the hypotenuse, or the radius. Well, the radius in this case, r is equal to 5. So since we have the three sides of the triangle, this implies that we are using exact values. Okay, because since we have two sides, we can use Pythagoras, which allows us to work out the exact values of sides. So if I want to write the cosine ratio now, I'm going to write the exact value of cosine as 3/5. The exact value of the sine ratio is going to be 4/5. And the tan ratio, or the slope, is going to be rise of 4 over a run of 3. Okay, so we're just using exact values for this whole problem, except now, because we only have the ratio description of this angle, we now need to use our calculator to translate that ratio description of this shape to the angle description of the shape. I can use either sine, cos, or tan and undo any one of those to get theta. So I'm just going to choose the first one. So I'm going to use the opposite, or arc cos. So when I use arc cos, I need to use the ratio. I plug in the ratio, and I calculate the angle. The angle of theta. It's really, really important that we keep track of when we're dealing with, and very clear when we're dealing with the number as a ratio. For the inverse cos, the input is a ratio, the output's the angle, versus when I'm dealing with the angle, when my angle input is in the cosine sine. In this case, the angle is the input for the cosine or sine. The output here is my ratio. So it's important to be clear when you're dealing with an angle with a ratio that determines whether you're using the inverse or the regular function. Okay, and that's very important to clarify. Now, if you think about it, it's relatively straightforward to decipher between the two, but it's important that you're clear and distinct about that. So when I put this into my calculator then, my input, my ratio 3/5, when I do my arc cos, my output's going to be my angle, and my angle theta I'm calculating to be about 53.13 degrees, and that's about right given those dimensions. So 53.13 degrees. So we have our ratio, which tells us the shape. We also have an angle, which tells us the shape. And we need to go to your calculator, go from one to the other. Make sure you know which function you're using, because if I'm going from ratio to angle, I need to use the arc cos. If I'm going from angle to ratio, I need to use a cosine.